Now let's go ahead and talk about the periodic table. The periodic table has gone through a number of different revisions. The um, gentleman who's basically recognized as one of the more important people in the periodic table's history is a guy by the name of Dmitry Mendeleev. He was one of many to propose an arrangement of elements by mass. He did that in 1869, which, man, he did that when he was 35. I'm 37, and well, I don't know. I guess I just have to live with that. Anyway, he's the father of the periodic table. He grouped elements by properties and left gaps, hypothesizing that other elements would be discovered. And here's his early kind of organization and representation of the periodic table. Elements that had already been found. And I believe at this time there were probably some elements that were ultimately omitted. But basically, here's his kind of construction of the periodic table. And I presume that this right here says something about the periodic table or chemistry, but it's the Cyrillic alphabet, I think. Anyway, a very significant player in organization of the periodic table. I read a book a few years ago that had all of these different historical organizations of elements, and it's really kind of fascinating how it evolved over time. But here we go, that's where we are. Now, the modern periodic table is, well, it's organized like such. In this class, you know how you're told to memorize the first 36? Well, you're basically living in these first 4 blocks. This first, yeah, right about here. That's not to say we will never address anything down here, because we do talk about gold, AU. We talk about silver, AG. And periodically, you know, we'll throw something like Ognesian in there. But basically, this is the construction of the periodic table. So elements are ordered by their atomic numbers, which means their number of protons. In this arrangement, elements in the same column, so columns go up and down. I always have to remind myself columns versus rows. Columns are on a house, they go up and down. And rows are, I suppose they could be on a house, but they go left to right. So elements in this same column have very similar properties. So what that means is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they all have very similar properties. Now these bottom 2 rows, lanthanoids and actinoids, we will not really talk about these very often. I don't know that we ever address them in this class. If we do, it's just kind of like a composition or a makeup of them. Now, rows are known as periods, and columns are known as families or groups. I will probably more commonly use the terminology group, just because that's what I'm accustomed to saying. Now, those groupings, or the kind of organization of all of the elements of the periodic tables, they're very simple. There's only 3 of them: metals, metalloids, and nonmetals. The awesome thing about this is we kind of have some context for a metal, like this electrical wire stripper here. I made these, which if you're taking the Gen Chem 1 lab, spoiler alert, look at this. This is a battery right here, and I gotta make a circuit. Ta-da! And then I can do, well, this is just because these are fancy lights. I can, ta-da! Now it's different colors. Anyway, I had to use that metal strip. The point is, though, this is probably, there's probably some iron in this. Okay, so that's a metal. Good to know. I have some tangible idea of what a metal is like. This could probably conduct electricity, much like copper, the copper wiring that's within this set of lights here. Nonmetals, on the other hand, well, heck, what's a nonmetal? I suppose oxygen, that's a nonmetal. But in terms of solid nonmetals, that might be a little bit of a stretch for me to kind of envision there. Metalloids. Well, the awesome thing about metalloids is that they've got some properties that are like metals, and they've got some properties that are like nonmetals. So it's almost like, I don't know, the creative person in the room was like, well, they're kind of like metals, but they're not fully metals, so we can't call them metals. They're kind of like nonmetals. They're not really nonmetals either. Let's go with metalloids. I always feel like whenever you throw that oids at the end of a word, I don't know. For some reason, I'm thinking about like androids and Star War, not phones necessarily. But anyway, these are your organizations, or this is your organization for the periodic table. As you can see, the vast majority of the periodic table is grouped into metals. Okay, if you want to take it a little bit further, you have main group elements, transition elements, and inner transition elements. If you wanted to organize all of this, or organize the periodic table completely, it would look like this. Where you have your main group elements right here, you have your TE transition elements, and then you have your ITE inner transition elements right here. We'll talk about them a little bit later on whenever we talk about organization of, or basically what an atom looks like. This information out here, valence electrons are in S and P. They follow the octet rule. I would just suspend that, that's a little bit of a spoiler. I wouldn't worry about that for the time being. We'll revisit that later on this semester. Okay, so since we have groups and groupings of elements on the periodic table, they have similar properties. There are some that are kind of so similar to one another that they get a unique name. For instance, this group 1A, which I will refer to these as group 1. Sometimes I'll say group 1A. Over here, this I will also refer to as group 3, 4, 5, 6, 7, and 8. These B groupings, I generally don't refer to those as anything but the transition metals. And you can see that there aren't really enough that are very similar to one another, with the exception of these coinage metals. But this group 1 and group 2, these are alkali metals and alkaline earth metals. Group 6 or group 6A, these are your chalcogens. Group 7A are your halogens, and then this is kind of concealed there by my head, but these are your noble gases. Group 8 are your noble gases. So these are elements that are similar enough to one another that they merit a unique name, not just group 8. Okay, which element is a halogen in the third period? Okay, so this information, or what this is asking you for, is it's asking you to look on the periodic table, and I'll pause for a moment and let you do that. And basically it's saying it's a halogen, so that's a specific row or a specific column, and then the third period. So that means it's in the third row. So it's almost like you're getting coordinates here. Okay, now I'm gonna use my computer and jump back and forth to ptable.com, and I'm looking for something in the third period, so the third row, and it's a halogen. Halogens are group 7, so I'm actually looking at chlorine as the correct answer there. Which element is a metal in group 14? Now, group 14, this is kind of it's almost like I misled you. This would be the same as group 4 / group 4A. And this particular group is kind of tricky because this includes nonmetals. I'm gonna write NM, M-oids, metalloids, and metals. Okay, so within this group you've got carbon as your nonmetal, silicon and germanium as your metalloids, tin and lead as your metals. And well, only lead is found on our list here. Okay, which element is the most similar to phosphorus? So similarity we're looking at in the same group. Phosphorus is in group 5, and in that group is nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so we've got arsenic is right below it. So not potassium. That's kind of a tricky question because you're looking at phosphorus. Oh, well, that starts with a P. Not sulfur, not silicon. Arsenic is the correct answer. Now, I hope that was all helpful, and I hope that you got something from this chapter 2 information. I would go ahead and tackle my homework, make sure that I'm good for that. And if you have any questions, please contact me or go to your SI sections. And yeah, best wishes. Thank you very much.